All right, hey students. Last class we did section 2.7 and 2.8 and we did them kind of really fast. So what I want to do is I wanted to make this video because I was upset that we rushed through it and I didn't get to get all the points across, and then we need to move on Tuesday. So what I'm going to do is I'm going to go over section 2.7 and 2.8 again in this video and add in a couple things I didn't do it on Thursday, and also just you know, do it a little bit slower. So okay, so we're talking about derivatives now. So we spent all this time until now talking about limits, and now we're going to talk about derivatives. The main goal of section 2.7 and 2.8 is the following. I'm going to give you two things. I'm going to give you a function f, so we're given a function f, and I'm going to give you a point on the graph, so point on the graph. And then I'm going to ask you to find the slope of the tangent line at that point. Let me go ahead and draw a quick picture here. So here's just some random graph, let's say. Okay, so I'm going to give you some kind of graph or some kind of function, and I'm going to say, okay, we have this point on it. So what am I giving you? Two things. I'm giving you the function, in other words, some kind of curve, some graph, some function, and a point on the graph. And I'm going to ask you, find the slope of the tangent line to the function there. So our goal is to find the slope of the tangent line. Okay, so before I actually derive, you know, how to do that, we have a formula for it, as I showed you last class, but I'll derive the formula again. Before I give you the formula for it, I just want to talk about some notation real quick. So when I have a point on a function, whenever you give me a point, you have to give me how many numbers? You have to give me two numbers. You have to give me the x-coordinate and the y-coordinate. So I have to say, you know, find the slope of the tangent line at the point 2, 7. You have to give me the x and y coordinate, 2, 7. 2 is the x-coordinate, the y-coordinate 7. So normally when you specify a point, you have to give me 2 points. However, when you do the homework or you read the examples in the book, a lot of times they're not going to give you the x and y coordinate. Sometimes they will, but sometimes they'll just give you the x coordinate. And the reason why is because if you have a function, if I just give you the x coordinate, then you can figure out the y coordinate on your own by plugging into the function. Also, once you tell me the x coordinate, there can only be one point on the graph with that x coordinate. For example, if I say the x coordinate of this point is 3, so let's say this number is 3, then that's the only point on the graph where the x-coordinate is 3. There can't be another point, because if there was, it wouldn't be a function, because it wouldn't pass the vertical line test. Okay, so sometimes instead of them giving you both the x and the y-coordinate, if you're talking about a function, they'll just give you the x-coordinate. Sometimes they'll give you both. Now, if they only give you the x-coordinate, how do you find the y-coordinate? Because we're going to need both coordinates. How do you get the y-coordinate? So here's what I'm asking you. If you have a function, and you have a point on the function, and you know the x-coordinate of the point on the function. So just like here, function, point, and here's the x-coordinate of the point on the function. How do you find the y-coordinate? The answer is you plug the number 3, the x-coordinate, into the function. So let me just do a quick example here. Let's say the x-coordinate of the point on the graph is 3. Then what's the y-coordinate? Well, it's f of 3. Okay, so you just plug in 3 to the function, and you get the y-coordinate. Okay, let me change it on you. Let's say this number was 7. Okay, so x-coordinate of the point is 7. What's the y-coordinate? Okay, what's the y-coordinate over there? F of 7. Okay, let me just make it slightly more complicated. Let's put a letter here. Let's say the x-coordinate of the point on the graph is A. Okay, what's the y-coordinate? The answer, again, just plug that into the function, f of A. There's the answer. So basically I'm talking about the point A, comma, f of A. Okay, so A is the x-coordinate, f of A is the y-coordinate. Let's do another one. Let's say B. So again, we have a function, a point on the function, and the x-coordinate is b. So instead of saying 3, it says b. Now I'm asking for what's the y-coordinate here? And the answer is f of b. Okay, let's change it one more time. Let's say the x-coordinate of some point on the graph is x. How do you find the y-coordinate? Again, just take it and plug it into the function, and you get f of x here. So what I'm trying to tell you is, if you know a point on the, if you have a graph, so if you have a function, and you know the x-coordinate of a point on the graph, how do you get the y-coordinate? The answer is plug it into the function. In the picture here, if this is 3, then the y-coordinate is f of 3. Okay, so that's how that works. So plugging a number into the function will give you the y-coordinate. If this is the x-coordinate, that'll be the y-coordinate. And this point, if I say write it down as a whole point, you would say 3, comma, f of 3. So you give me the x-coordinate 3, y-coordinate f of 3, 3, comma, f of 3. Okay, so that's what it means, you know, when you plug in a number to a function, you get the y-coordinate. Now I want to talk about the notation. You see this derivative notation. So you see like this f prime. So you'll see this sometimes with the prime here. What does that mean? That means the slope of the tangent line. So f is the function. When you plug numbers in, you get outputs, you get y coordinates. But when you plug in numbers to an f prime, you're going to get a slope. So if I say you have a point on the graph whose x coordinate's 3, and I say what's the y coordinate, f of 3. But if I say what's the slope of the tangent line there, then it's f prime of 3. So this is slope of the tangent line. Okay, slope of the tangent line. So at the point where the x coordinate is 3, what's the slope of the tangent line? The notation is f prime of 3. One way to say that is f prime of 3. The other way to say that is it's the derivative of the function at 3. Okay, let's say this number was 7 then. Okay, so I'm just changing it. What's the y coordinate of the point? F of 7. But if I say what's the slope of the tangent line there, the answer is f prime of 7. Okay, so f prime just stands for a slope. F will give you y coordinates. When you plug in numbers, the output will be y coordinates. But if you plug in numbers here, the output will be the slope at that point. Okay, so like in this picture here, since I put a 3 here, there's the point on the graph. If I draw the tangent line, let's go ahead and try to draw something that looks like a tangent line. Okay, so then if I say what's the slope here, the notation for the answer, f prime of 3, because that's 3 down there. Again, if that was a 7, this slope here would be f prime of 7. Okay, if I want to know the slope, and this number here is a, what's the slope? Answer, f prime of a. Okay, so the difference between f and f prime, f gives you y coordinates, f prime gives you slopes, and f prime is also called the derivative. So let's just go through the rest of this table here. If the x coordinate down there is b, in other words, I have a point on the graph, x coordinate's b, then what's the slope of the tangent line there? F prime of b, or another way to say it, the derivative of the function at b. Here, if this number was x, what's the slope of the tangent line? F prime of x. Okay, so I just wanted to point out the difference between an f and an f prime. F gives you what kind of things? Y coordinates. If you plug in an x coordinate, f will give you y coordinate. But if you want to know the slope, again, to find the slope, you don't have to tell me the x and y coordinates to let me know what point you're talking about. Just tell me the x coordinate. You tell me the x is 3, I know what point you're talking about. What's the slope there? F prime of 3. Plug it into 3. Plug it into the derivative. Plug it into f prime. Okay, so let me go ahead and derive the formulas. I gave you these formulas last time, but I want to go through the derivation one more time. So the story is that to find the slope of a tangent line, you need to take the limit of slopes of secant lines. So let me go ahead and draw a picture here. Again, I'll just draw some random function. I guess my random function always looks the same. Okay, but let's say I want to find the slope of the tangent line right here at this point. So again, that's what it's going to be given to you. You're going to be given a point. You're going to be given a function and a point. This point here is the important one. This is the one I want the slope at. So we'll call this point P, but let me give it x and y coordinates. So the x coordinate I'm going to call A, and the y coordinate I'm going to call, well, what is it? If the x coordinate is A, what's the y coordinate? Answer, f of A. Okay, so that's f of A. Again, that's the story there. This A and f of A, the reason I'm writing f of A and f of A is so I can derive the formula for you. But that's the important point, okay? So that's the point that's given, and that's the function that's given, and I want the tangent line there. But to find the slope of the tangent line, you can't find the slope of the tangent line right now, because that's just one point. How many points do you need in order to find the slope? The answer, you need 2 points to find a slope. So what you do is you look at secant lines, and the way you do that is you pick another point close to P. So let's say we start over here, and we'll call this point Q. There's nothing special about this Q. P is the point that's given in the problem. Find the slope of the tangent line at P. Q is just some other point. So what I'm going to do is I'm going to find the slope of the tangent line from P to Q, and then we're going to move Q and move Q closer to P. Don't move P, because P is given. That's the point I want to find the slope at. So what I'm going to do is, because this can change, I'm going to call it x, okay? So x, like, it's a variable, so it could change, whereas A can't change, okay? So A is fixed there. Well, if that's x down there, that's the x coordinate, what's the y coordinate at this point? And the answer, f of x. That's the y coordinate. Now, how do I find the slope of the line between the P and Q? So we'll call it slope of the secant line. Okay, so I'll just, this notation is not that important, but for right now I'm just saying the slope of the line between P and Q, or the slope of the secant line, well, the formula is y2 minus y1 over x2 minus x1. And let's see, so these points that are on top of each other, this is the x coordinate and y coordinate of the second point, this is the x coordinate and y coordinate of the first point. Let me just call this point the first point, let's call this point the second point. So then to use this formula, let me go ahead and copy down those minuses. What's y2? y2 is the y-coordinate of the second point, which is f of x. We got f of x minus y-coordinate of the first point, this point, y-coordinate f of a. Down here, x-coordinate of the second point. Here's the second point, x-coordinate is x. X-coordinate of the first point, x-coordinate of this point is a. Okay, so that right there, it's called the difference quotient, okay, because there's differences and there's a quotient there. That's the slope of the secant line from P to Q. But that's not what I want. I want the slope of the tangent line. So how to find the slope of the tangent line? What you do is, you take this point Q and you move it closer and closer to P. How do you move it closer to P? Well, let's just look at the x-coordinates. Remember, this A can't change. This P is fixed there, but the Q can change. So how do you move it to P? You got to make the x get closer and closer to A. As the coordinate of Q moves, this point gets closer and closer down here. So I guess in this picture here, that formula that's there is the slope of this secant line, okay? But the slope of the tangent line, so slope of the tangent line at P, the notation for it from the other slide is f prime of A. In other words, I want to find the slope of the tangent line at A, or A comma f of A. Okay, so slope of the tangent line, that's why I have prime here. It's a limit. Limit, we want x to approach A. So as x goes to A, of f of x minus f of A over x minus A. Okay, so that, we'll call that formula 1. Here, I'll put a 1 here. Okay, so that's the first formula for slope of the tangent line. There's a couple of different formulas, and it's almost the exact same derivation. Okay, I'm going to derive the other one in a minute too, but just understand that this formula here is one of the formulas that will help you find the slope of the tangent line at the point P. Okay, so let's go ahead and look at the definition now. Because in calculus, everything has to be defined, so we know exactly what we're talking about. So this is just me rewriting stuff. So here, we're going to be given a function and a point. Again, I don't have to give you the x and y coordinate here. I'm just saying the x coordinate's A. That's enough for me to tell you what point I'm talking about. So you're given a function and a point. Then the slope of the tangent line to the function at that point, which is also called the derivative of the function at that point, is this limit. Okay, so then the slope of the tangent line, we're not going to use that too much more, but I just want to emphasize that it's the slope of the tangent line. But this is the notation, f prime of A, or the derivative of the function at A. This is just the notation, so there's nothing, I'm not teaching anything here. If I want to ever write down, what's the slope of the tangent line somewhere, this will be the notation. F prime will be slope of the tangent line of this function at this point. But anyway, it's this limit here. Okay, and that's just provided this limit exists. So this keeps happening to us. Every time we're finding limits, you have to make sure the limit exists. So if you want to find the slope of the tangent line to a function at a point, you calculate that limit. And if that limit exists, that's the slope of the tangent line. And if it turns out that limit doesn't exist, then it doesn't have a tangent line at that point. And it's possible that you can have a graph where certain points, there is no tangent line. And we'll see some examples later. If that happens, here's what we're going to say. So if the limit does not exist, then we're going to say the function is not, okay, let's make sure we don't miss that word there. It's not differentiable at the point. So a function, you will say it's differentiable, has a derivative. So the word derivative, differentiable means has a derivative, has a slope. In other words, there's a tangent line there and it has a slope. And if we say it's not differentiable, that means there is no tangent line at that point. In other words, the slope of the tangent line doesn't exist. And the reason is because slopes of the tangent lines are limits. Okay, so that's one formula that we have, this one here. So memorize this, that would be a good idea. And I'm going to derive the second formula for you now. And again, it's not really any different. The only difference is the way I label things, but the idea is exactly the same. So I'm going to go ahead and draw another picture here. So one more time, arbitrary graph, but my graph's going to look basically the same because I'm not creative enough to make up different ones each time. So I'm going to give you that function and that point there. So that's the point P, and I'm going to call the x-coordinate A again. I'm going to call the y-coordinate, well, again, what is it? It's f of A. You plug in A to the function to get the y-coordinate. Okay, so we're given a graph, and we're given a point P on the graph. To find the slope of the tangent line there, what I'm going to do is pick another point Q, okay, just put it here for now, and we'll label the x and y coordinates of this a little bit differently so we get a different formula here. But what we're going to do is we're going to find the slope of the secant line that connects P and Q, and then we're going to move Q closer and closer to P, and that'll be the slope of the tangent line. So the x-coordinate of P is A. So that's getting messy. Okay, so the x-coordinate there is A. But now instead of calling this x, the way I derived the other one, I call this x. Instead, I'm going to call the distance, the distance between the x coordinates of these 2 points, I'm going to call it something. So instead of calling the x coordinate here something, I'm going to say, okay, what's the distance between those 2 x coordinates? I'm going to call it h. Again, it's just it's a relabeling of things. If I call h the distance from there to there, then what's the x coordinate at that point? Well, it's a, and then you got to go to the right h. So the x coordinate of this point is now a plus h. Okay, well if the x coordinate is a plus h, how do you get the y coordinate? The answer, f of whatever that is. So f of a plus h. Okay, so again, that's how you find y coordinates. Take the x coordinate, plug it into the function, you get the y coordinate. All right, now, so I just relabeled things slightly differently. Now let's go ahead and find the slope of the secant line from the points p, from p to q. It's still the same thing, y2 minus y1 over x2 minus x1. Just different labeling. So let's see. Let's once again call this the first point. Let's call this one the second point. So let's see. The y coordinate of the second point is f of a plus h now. The y coordinate of the first point is f of a. The x coordinate of the second point is a plus h. And the x coordinate of the first point, is a. Okay, so you simplify this a little bit, and well, I can't really do anything on top, so I'll leave the top alone. But the bottom, I guess the a's cancel, and you just get h there. So it's a slightly different looking formula, but there's the slope of the secant line connecting p to q. So how do you find the slope of the tangent line? Okay, slope of the tangent line, well, you know what you're going to do. Well, first of all, what's the notation? It's the same notation. Where do I want to find the slope? At p. P can't move. We're going to move q. So I want to find the slope of the tangent line at a. The notation for that, f prime of a. Okay, so you put a into f prime. F prime stands for slope of f at a. Slope of the tangent line to f at a. Well, what is it going to be? It's going to be a limit. We want to bring this point closer to here. How do I bring this point closer to here? Well, this time it's the h that we're going to have to change. Okay, so the way it is we want the distance from the x coordinate of this to x coordinate of this to get smaller and smaller. In other words, if h gets really small, then this point is moving closer to that. So it's going to be limit, what do you think? H goes to what? Well, the answer is going to be h goes to 0, because when this distance gets closer and closer to 0, that means this point is moving closer. And then of this thing here, f of a plus h minus f of a over h. So this is just a second formula. Okay, we'll call that formula 2. But it's just a different, slightly different formula, but telling you the exact same thing here. Okay, so limit as h goes to 0 of f of a plus h minus f of a over h. We'll also tell you the slope of the tangent line. If you use the first formula and you get the slope is 5, when you use this formula, you're going to get the slope is 5. If you use this formula and you get does not exist for the limit, for the slope, then the slope's going to be does not exist when you use the other formula. So they're basically equivalent formulas. So let me go ahead and mention real quick. So which formula are you going to use then when you're doing problems? Well, the answer is you could use either one. But the truth is, I think, depending on the way algebra is taught these days, I feel like there's certain functions I can make up where if you use the first formula, it's going to be really tough to use, and using the second formula is a little bit easier. But it really depends on how your algebra is. So if you're perfect on every little thing involving algebra, then either formula is totally fine. But again, if you're not good at things like dividing, synthetic division, things like that, or factoring polynomials that have huge degrees, anyway, certain types of algebra things, then you might want to avoid formula 1 and use formula 2. But if you're not good at raising things to high powers, things like that, then maybe formula 2 is not the way to go. So it totally depends. Okay, so let me go ahead and give you the definition of derivative again. Just it's the same thing I said before. I'm just going to write a different formula here. So definition of derivative. So once again, what are we going to be given? We're going to be given a function and a point. So a function and a point on its graph. And then I'm defining what's the slope of the tangent line at that point. What's the slope of the tangent line to the function at that point, which is also called the derivative of the function at that point. It's this limit. So slope of the tangent line is limit as h goes to 0 of f of a plus h minus f of a over h, as long as this limit exists. And once again, if the limit doesn't exist, that just means that you picked a point on the function where there is no tangent line. And again, we'll have to see examples. If you can't think of that right now, I'll show you some examples later so you can see that sometimes there's no tangent line at that point. Okay, But again, remember the slope of the tangent line is a limit, so since limits cannot exist, slope of the tangent line doesn't have to always exist. Usually they do, but they don't always have to exist. And if they don't exist, then we say the function is not differentiable at that point. Okay. So what I want to do is I want to practice a little bit. We did some of these again in class, but I want to just go ahead and do them again. I want to find the slope of the tangent line using each of the formulas so you see what happens, just to see a couple of things that can happen to you. So let's go ahead and try this one. This one says find the slope of the tangent line to the function. So we have this function f of x equals x cubed minus x at the point 2. And we're going to use formula 1. Okay. So to find the slope of the tangent line, well, first let's practice the notation. Let's find the slope of the tangent line to this function at x equal 2. The notation is f prime of 2. That's what we're looking for. Again, that's just a notation for now. Okay, and what is it? Well, let me get back this formula here to remind you what the formula looks like. Give me a second. Okay, so there was the formula again. Okay, so this is the formula for find the slope of the tangent line. And what I'm going to do is I'm going to change every single a to 2 because we're looking for f prime of 2. So I'm just going to write this exact thing down on the next page there. But that's going to be a 2, that's going to be a 2, and that's going to be a 2. Okay, so we get, it's going to be limit x goes to 2 of f of x minus f of 2 over x minus 2. Anyway, now it just comes down to finding this limit. If we find this limit, remember a limit is a number. As soon as I find this limit, I found the slope at that point. I'm not even drawing a picture yet. I'll draw a picture in a minute so you can see something about what the graph looks like. But anyway, I don't need to draw a picture to find the slope. So let's go ahead and see what this limit is. So now what I'm going to do, I'm going to copy down limit as x goes to 2 every step of the way and then see what happens. So first what I'm going to do is the bottom, I'll leave it alone, nothing to do there. But I'm going to figure out what f of x is, and I'm going to figure out what f of 2 is, I'm going to put them up here. F of x, well, that's f of x, the formula for the function. So we put x cubed minus x there. Okay, then what's f of 2? F of 2 means plug 2 into the function. Here I'm going to put these in square brackets just to separate the two, but you do not have to do that. But if I plug in 2 to the function, what do you get? You get 2 cubed minus 2. If you don't put these square brackets, at least put parentheses, because you're going to have to distribute the minus, and if you don't put anything, you might forget to distribute the minus, and it cause a lot of problems. So okay, so limit as x goes to 2. Now I'm just going to simplify the top. This is x cubed minus x minus 6, because that's 8 minus 2, so we got 6 in there. And we got x minus 2 here. Now, see, this is where the problem begins. Had this function I gave you been x squared minus x, this would have been no problem to factor, something you factor way back in math 30. But it's a cubic. Since it's power 3, those are things, there's not very much, there's not that many tools that we have to factor cubics. Let's see, what is there? There's factor by grouping. But usually you do that if there's 4 terms. There's only 3 terms up there. And we do have to factor because let's take a look at this limit. If I say what's the limit of the bottom, it's a polynomial. You plug in, you get 0. So limit of the bottom is 0. Limit of the top is also 0. So this goes to 0, this goes to 0. Try plugging in the 2. You'll see you get 0, top and bottom. So when you get a limit like that, what are you supposed to do? You're supposed to do some algebra. Okay, so I'm going to do some algebra. And the algebra that I'm going to use is I'm going to factor. So again, you see how Formula 1 runs into problems sometimes. Now the trick is, since you plugged in 2 to the top, you get 8 minus 2 minus 6, you get 0. That means 2 is a root of this polynomial, and then there was a result back in algebra that says if 2 is a root, then x minus 2 is a factor. Okay, so I know how to factor it, at least a little bit. I know x minus 2 is one of the factors. To get the other factor, there's a couple of ways you can do it. You can do long division, in other words, divide this by x minus 2. Do long division, or you can do synthetic division since we're dividing by something that has degree 1. Synthetic division is a trick you can use for dividing that's a little bit faster, but you can only do it if you're dividing a polynomial by something that has degree 1, and this term has degree 1. So let me go ahead and do the synthetic division over here. If I want to divide this by x minus 2, you put a 2 in the box here, meaning whatever makes this 0, you put that in the box. So since 2 makes this expression 0, you put that there. Then you put the coefficients of this polynomial over here. It's going to be 1, 0, negative 1, negative 6. Don't forget the 0, because this is the x cubed term, this is the x squared term. Since there's no x squared term, you have to put a 0. X term and then constant term. Then synthetic division says you bring down the first number. Then if you have a number under the line, you multiply it with the number in the box. So 1 times 2, and that goes here. Then if you have two numbers above the line, you add them and put them below the line. So you add that and you get 2. Now again here, 2 times 2, 4. Add those, you get 3. 3 times 2 is 6. Add those, you get 0. And then I put a box at the end there. If this last thing is 0, that means that this was indeed a root. In other words, this was a factor. And the other term is given by this. Now if you forget where these things go, this is the constant term, this is the x term, this is the x squared term. So it's 1x squared plus 2x plus 3. So it's x squared plus 2x plus 3. Anyway, see, you had to be good at division to do that. But now that we're at that step, now we're pretty much done because the x minus 2's cancel now. And once the x minus 2's cancel, that's great news because now the thing I'm taking the limit of is just a polynomial and I can plug in to get the limit. So it's 2 squared plus 2 times 2 plus 3 and 4, 4, 3, 11. Okay, so that's basically the end of the problem. It said find the slope of the tangent line to this function at this point. You calculate a limit. We got 11. Slope of the tangent line is 11. Now I'm going to draw a graph just so you see what's going on here. You don't have to draw the graph. But again, just so we can have an idea of what we just did. Like, what did we just do? We found, so first I'm going to draw this graph here. If you don't know what x cubed minus 1 looks like, totally cool. Let me go ahead and draw it real quick here. Let's see, I know it goes through -1 and +1 and 0. So the graph looks something like this. We can talk about this in way more detail at some other point. Don't worry about it right now. But now they said at the point 2, so we're looking at this point here. Okay, so this is the point we care about. This is the point P. So we have this graph, and then here's the point P. And I'm trying to find what's the slope of the tangent line at that point. And so now if I drew a tangent line, I guess the graph would keep going up like this, but the tangent line would be something like that, and the slope of this tangent line is 11, and the notation is f prime of 2. In other words, the slope of the tangent line to f at the point 2 is 11. And again, one more time, if it makes you feel weird that when I told you a point, I just told you the x-coordinate. Once I tell you the x-coordinate, you know what point I'm talking about, because there's only one point in the graph with the x-coordinate 2. The y-coordinate, if you're dying to find it out, how would you find it out? You plug in 2 to the function. When you plug in 2 to the function, what do you get? The answer is you get 6. And that's why we got 6 over here. Okay, the 6, that was just the y-coordinate of that point that we're talking about. So the slope of the tangent line at the point 2, 6, or I can say the slope of the tangent line at 2. That's the same thing, basically. Because once I tell you 2, the 6 could be found somehow, because it had to be 6. And the slope of the tangent line is 11. Okay, so that's how that goes. Now what I'm going to do is I'm going to do the exact same problem again using the other formula, just so you can see what happens if you try the other formula. Remember, the one we just did was a little bit nasty because we had to do some kind of synthetic division or some kind of factoring somehow or other, which again, you should definitely know it, but still, it's just know that Formula 1's not the best thing, because sometimes the algebra you have to remember, is long forgotten. So let's try our best not to forget it. But let's try this formula here. So same exact question. Find the slope of the tangent line to this function at this point. Okay, so I'm going to use the second formula. So the slope of the tangent line, again, the notation is f prime of 2. So slope of f would be f prime at 2. Plug in 2 there. And I'm just going to use the second formula now. And if I can find the previous slide with the second formula in it. Okay, so this was the second formula here. And has the h goes to 0 business. But anyway, what I'm going to do now is I'm going to change all the a's to 2. So that's going to change to 2, that's going to change to 2, that's going to change to 2. Notice it says h goes to 0, so there's nothing, those don't change. Just all the a's, change them to 2. And it's going to say limit h goes to 0 of f of 2 plus h minus f of 2 over h. Okay, so limit h goes to 0. The bottom I'll just leave as h. Now let's see what these things are. Let me put the minus sign here. This is that minus sign. F of 2 again means plug in 2 to the function there. So it's 2 cubed minus 2, which we did in the last problem. It was 6. But now what's this f of 2 plus h mean? Well, whatever's in the parentheses, you need to plug that into the function. So plug 2 plus h into the function. So here's the function. every x that you see, you're going to change to what's in this parentheses. So f of 2 plus h, you're going to put 2 plus h here and 2 plus h here. So it's going to be 2 plus h cubed minus 2 plus h. If you're not sure, put it in parentheses. And this time, it's very important to put this parentheses here because this minus is going to have to get distributed. So look what you have to be able to do this problem. You have to be able to cube this parentheses here. So if you don't know how to do that, well, let me say it like this. That's easier to do than factoring, in my opinion, because people remember how to do this and people forget how to do the other thing. There's a couple of ways to do this. Some people know a formula that they could cube it right away. Some people will do it like this. They'll write 2 plus h, 2 plus h, and then another 2 plus h. What they'll do is they'll multiply those two out, get the answer, and then multiply it with this one and get the answer. Okay, so try it, at home, try it right now, pause the video and try it, but you can multiply this all out, get the answer, and then multiply it all out with the 2 plus h. What I'm gonna do is I'm just gonna do it all at once here. So I'm gonna say, okay, assuming you know the formula or you did it, you paused the video and you got it. Let me see if I can remember actually what the formula was. I think this is gonna be, well, okay, so it's like 2 cubed plus, let's see, 3 times 2 squared times h, plus 3 times 2 times h squared plus h cubed. This whole mess is the 2 plus h cubed. Again, if that looks really weird, it's because I'm applying a formula that, if you don't remember it, then don't do it that way. Go ahead and multiply all this out. So it still sucks. See, in this problem, there's something that sucks, but the difference is, do Formula 1, it's a factoring thing that sucks, and in this one, it's a cubing binomial kind of thing that sucks. Well, let me go on. This minus is this minus. I'm going to distribute the minus. It's minus 2 minus h. Let me just write minus 6 here because this was minus 6. All right. If you can handle that, though, then the rest of it's going to be easy because I'm going to have to do some factoring in a minute, as you'll see, but it's super easy compared to the other one. All right, so let's see here. This is 8, and that's 12. So 12h, and then this is 6h squared plus h cubed minus 2 minus h minus 6. Now here's one thing I want you to notice about this formula. The top part, almost every term has an h, and the terms that don't have an h cancel because it's 8 minus 2 minus 6. Let me go ahead and just cancel the terms that don't have an h, and that's always going to happen if you did the problem right. So this is going to be limit h goes to 0, 12h plus 6h squared plus h cubed minus h over h. Now let me go over here. So limit h goes to 0. Now what I'm going to do, what kind of limit is this? Well, the limit of the top goes to 0 because you plug in 0 for h, you get 0. Limit of the bottom is also 0. So this is a limit of the type 0 over 0. What do you do when you have a limit of the form 0 over 0? You do algebra. In this case, we're going to factor. I'm just going to factor in h. Again, this is what's always going to happen if you do the problem right. All the terms that don't have an h are going to cancel. And then since every term has an h, you can factor in h out of all the terms on top. And what do we get? We get 12 plus 6h plus h squared minus 1 over h. And now these h's cancel. And you get limit h goes to 0 of 12 plus 6h plus h squared minus 1. And now you can just plug in the 0 for the h. Look what you get. 12 plus 0 minus 1. Oh, look, 11. That was the slope that we got using the other formula. So anyway, we have two different ways of doing it. It just depends on which algebra you like. In general, know how to use both formulas, and anytime you do a problem, you should try it using both formulas. But oftentimes, you'll see this formula is a lot easier to use than the other one. I want to mention one other thing here. Whenever you're doing limit problems, make sure you write limit every step of the way, okay? Until you're about to plug in. So we all the way to here. Then we said, okay, now we'll plug in 0. As soon as I plug in the 0, I plugged it in, I didn't write limit anymore. And then our answer is 11. Okay, so in this problem, f prime of 2 is 11, which we already knew from the other way that we did it. Okay. Now, that was long already, but I do want to try another problem. So I'll do them a little bit faster, especially since we did them last class. I also want to show you some different notation or slightly different way the problem can be worded. So let's take a look at this question. Okay, again, what am I going to be giving you? A function and a point on the function, or on the graph of the function. and I want you to tell me the tangent line there. And the last problem was just find the slope of the tangent line. This problem is asking you to find the equation of the tangent line. So in other words, if you get a question like this where it says find the equation of the tangent line, you still have to do everything we did before. In other words, find the slope of the tangent line first, and then you can find the equation of the tangent line afterwards. Okay, but now look how they wrote this. So find the equation of the tangent line to the curve y equal x plus 1 over x minus 1 at this point. Okay, so in the other problem, they would have had an f of x here instead of a y. But that's basically the same thing. If they write f of x here, you're thinking of it as a function which has a graph. And if you put a y here instead, it's still like a function, but it looks more like an equation in two variables, whatever. It still has a graph. So this is some graph, okay? Just a function. Think of that as the formula for the function. And at the point. Now another problem, another thing was, when I told you what point we're talking about, I only gave you the x coordinate. But this time I'm giving you the x and the y coordinate. And when you use the formula though, you're only going to need to use the 2. The 3 will show up anyway, but you only need to use the 2. Okay, so first the slope. That's the first thing we're going to do. Okay, so first find the slope, and the slope is going to be, so I'll use m, but the notation for it, f prime. They didn't use an f, so let's just say this is f here. Okay, that's f of x. So we're looking for f prime of what? Of 2. Okay, so f prime of 2. If I'm going to use formula 1, one more time to remind you what formula 1 looked like. So it was like that. Okay, and what I'm going to do is I'm going to change every a here. So this a, this a, this a, this a, all to 2. So this is going to be limit as x goes to 2 of f of x minus f of 2 over x minus 2. And then you're just going to simplify this like crazy until you can find the limit. So limit as x goes to 2. Okay, so the denominator is x minus 2. The top, here's the minus sign. F of x, you're going to put the formula for f of x there. So we got x plus 1 over x minus 1. F of 2, you have to plug 2 into all this. If you did that, you get 2 plus 1 over 2 minus 1. When you calculate that, you're going to get 3. That's the y coordinate, basically. You're plugging in 2 to the function, get the y coordinate. So if they don't give you the y coordinate, it still shows up when you do this limit. Okay. X plus 1 over x minus 1 minus 3 over x minus 2. Now I do have to simplify the heck out of this. This is a rational expression, and if you're trying to find the limit of a rational expression, you would love to plug in, but you can't, because when you plug in 2 to the bottom, you get 0. When you plug in 2 to the top, you get 3 minus 3. So you get 0. So you have to do some algebra. Okay, so this top's going to 0, this bottom's going to 0, so we're going to do some algebra. So we get limit x goes to 2. What algebra am I going to use? Okay, in class I think I did one way. Let me try something different just so you can see a second way. What I'm going to do is I'm going to multiply the entire top by x minus 1 because I want to try to clear the denominator out of there. So I'll multiply the entire numerator by x minus 1, and then I'll multiply the entire denominator by x minus 1. So we have x plus 1 over x minus 1 minus 3. I'm doing this times x minus 1. There's the top. Bottom, x minus 2, x minus 1. Again, it's just a different way that I did in class. Try to understand both ways, but it's almost identical. Now I'm going to distribute the x minus 1 over here. When I multiply this expression times x minus 1, the x minus 1's cancel, and I just get x plus 1. And then when I multiply this, I'm going to have to distribute the negative 3 times all that. Let me go over here. This is limit x goes to 2. Okay, so x plus 1 minus 3, x minus 1. I'll distribute the minus 3 in the next line. Here we have x minus 2, x minus 1. Okay, so now x plus 1 minus 3x plus 3 over x minus 2, x minus 1. Let me simplify a little more. X minus 2, x minus 1 on the bottom here. On the top, when you combine like terms, this here is negative 2x, and the rest is plus 4. And what I'm doing is I'm factor out a negative 2, because the thing is, I still can't plug in to find the slope. So I want the slope, I want to plug in, but I can't because, what's the reason? Because the denominator has an x minus 2. This is the problem. Why is x minus 2 the problem? Because if you try to plug in 2 to that, you get 0. See, this is not the problem. You can plug 2 there, you don't get 0, no problem. So I want this term out of here. So what I want to do is I want to cancel it with something up here. So when you factor the negative 2 out, you get x minus 2, and look, now the x minus 2's cancel. So this is gone, and you get limit as x goes to 2 of negative 2 over x minus 1. Now it's the limit of a rational expression, but it's a rational expression that I can plug into. So I'll just go ahead and plug in, and it's negative 2 over 2 minus 1. So the answer is negative 2. That's not the final answer to the question, because the question said find the equation of the tangent line, but we found the slope of the tangent line. It took a lot of work, but the slope of the tangent line is negative 2. Okay, so how do you find the equation of the tangent line? Well, I'm going to need to pull out another piece of paper here. Okay. So the next thing we're going to do is find the equation. So the equation of the tangent line. Well, you're going to use this. But in order to find the equation of a tangent line, what do you need? To find the equation of any line, you need a slope and you need a point. So I know the slope is negative 2. Right, that's what we got down here, negative 2. And the point is 2, 3. So if they give you the x and y coordinate, then you're great. But once again, if they only say find the slope of the tangent line at the point where x is 2, what's the y coordinate? How do you get the 3 in other words? Take the 2 and plug it into the function. So if you plug in 2 to this mess, you'll end up getting 3. Then you plug all that in here. So let's see. Basically the y1, the m, and the x1, you're going to fill in. So the m, I'm going to change to negative 2. This x coordinate here, this 2 is x1, and the y coordinate here is y1. Fill that in, simplify it. You get negative 2x plus 4. If you add the 3, the answer is y equal negative 2x plus 7. So this function, I don't know what the graph looks like, but at that point, the slope of the tangent line is negative 2. The equation of the tangent line is negative 2x plus 7. Okay, let me go ahead and draw some kind of graph here. Again, you don't have to worry about how come the graph looks exactly like this. I do know that it has an asymptote at 1, and it has a horizontal asymptote at 1 also. You should know those things because we talked about definition of vertical and horizontal asymptotes. So you should try that later, but that's not what we're talking about right now. Okay, anyway. So the graph looks something like this, so here, and something like this here. And at the point 2, 3, so they're talking about this point, let's say here. Okay, so that's point 2, 3. The tangent line there, if I was to draw a tangent line, okay, so something like that, then I know the slope of this is negative 2. And if I wanted to, okay, so the slope of that tangent line at this point is negative 2, and the equation of that line is y equal negative 2x plus 7. Okay, so that's the story there. Now we did that problem using Formula 1. I'm going to do it again. I think I won't do the equation of the line again, but we're going to do the problem again using Formula 2. So you find the slope again. So we'll find the slope again, we'll get negative 2, and then to find the equation of the tangent line, we'll do exactly this again. Okay, so I won't do it again. Well, once you know negative 2 and have the point, you just fill it in, and the equation of the tangent line would be negative 2x plus 7. Y equal negative 2x plus 7. But let's go ahead and use the second formula here and find the slope. So again, it says find the equation because I already did it once, I won't do it again. But let's find the slope using Formula 2. So if I'm going to use Formula 2, remind you again what Formula 2 looked like. It looked like that. So what I'm going to do is I'm going to change all the a's to 2, because a stands for the x coordinate of the point we're finding the tangent line at. So we're finding it's at the point 2. Okay, at the point 2 comma 3. This is a right here. This is f of a. Anyway, so I'm going to take that out of the formula, and every a changes to 2. So we're looking for f prime of 2. This is limit h goes to 0. It was f of a plus h, so it's f of 2 plus h, minus f of a, so f of 2 over h. Okay, so let's fill this stuff in and see what we get. So limit h goes to 0. The denominator is h. Up here on top, I'll put the minus sign. F of 2, well, 2 ways to find f of 2. One, it's 3, remember, because that's the y coordinate. But another way to do is plug in 2 to the function. So plug in 2 there, you get 3 over 1, so you get 3. So anyway, this is 3. F of 2 plus h is a little more complicated. What am I saying to do? I'm saying whatever's in the parentheses here, plug that in for all the x's. See the x's? I see 2 of them. So that x is going to change to whatever it says in the parentheses. So that's going to say 2 plus h plus 1. Down here, this x is going to change to that whatever's in the parentheses again. So it's going to be 2 plus h minus 1. So this is 2 plus h plus 1 over 2 plus h minus 1, like that. You could put parentheses around the 2 plus h if you want. It's unnecessary here because there's no distributing or multiplying or any negatives or anything like that. But you could put it if you wanted. All right, now let me go ahead and simplify this. Limit as h goes to 0. Okay, So first thing I'm going to do is this fraction is a little bit ugly, but I can simplify it a lot because this is h. Okay, so here's the h, here's minus 3, and this is h plus 3, and this is h plus 1. Okay. Now one way to do it, the way we did the last problem, is I would have multiplied top and bottom of this big fraction line by h plus 1 to try to clear the denominators. This time let me go ahead and do it a different way, but you can try it that way too. Let me instead do it the way we did it in class, where I try to get a common denominator here. So since this has an h plus 1, let me get an h plus 1 here. So I'm going to multiply top and bottom of this by h plus 1. Okay. And then we get, let's see, h plus 3, h plus 1, minus, now here I'm going to distribute the 3 up there. The denominator is h plus 1. Don't distribute the 3 down there. But this is 3h plus 3 over here. Well, I left the minus sign here. We'll deal with that in a second. So this is limit h goes to 0 of h plus 3 over, well, here's what I'll do. I'll write it so that it has just one, h plus 1 is a common denominator. And then, so since they both have the same denominator, that's the denominator of the answer. And then you do h plus 3 minus that stuff. And when you minus that stuff, distribute the minus. So it's going to be minus 3h minus 3. And the denominator down here is h. So we have that. Okay, let me simplify more. So here's the h. Here's the h plus 1. And up here, it's h minus 3h. Right, those are like terms. So you get negative 2h. Okay, and then 3 minus 3. Is that really what you get? 3 minus 3, I guess it is. So you get 0 there, so that's all you have there. All right, that's fine. Now what I'm going to do, since we have a fraction here and not a fraction here, I'm going to put a 1 under here. So that way I'm dividing fractions. When you divide fractions, you're supposed to flip the bottom one and multiply. So this becomes limit as h goes to 0, negative 2h over h plus 1 times 1 over h. I flip the h over 1, it becomes 1 over h. And these h's cancel, and you get limit h goes to 0 of negative 2 over h plus 1. And now take a look. We were doing a limit. It was kind of nasty. Up here, when we first started, if you tried to plug in 0, you get division by 0. You get 0 in the denominator. If you plugged in 0 up there, you would get 3 minus 3 after you plug it all in. So you get 0 on top and bottom. So this is a 0 over 0 type problem. That's why I did all this algebra. But after I did all the algebra, the h canceled. That's what you want to happen when you use formula 2. Your whole goal is to get the h that's on the bottom to cancel, because once it cancels, then you can plug in 0 for the h. So now I plugged in the 0 for the h. I mean, now that I got the h's to cancel, these two cancel. Now I get that. Now I can plug in. Once you plug in again, remember, you don't have to write limit anymore. So this becomes negative 2 over 0 plus 1, so negative 2, which was the answer we got for the slope using the other formula. Okay, so anyway, that's some practice on using both of these formulas. Okay. So one more time, remember what our goal was. Okay, so our goal, I'm going to try to find this slide over here that's a little messy now. But okay, so one more time, our goal was, given a function and a point on the graph of it, find the slope of the tangent line. The way you find the slope of the tangent line, you pick either formula 1 or formula 2, and you go. And when you find the slope of the tangent line, it's going to be a limit. If the limit exists, that's the slope of the tangent line. If the limit doesn't exist, then it doesn't have a tangent line there, and we're going to say it's not differentiable there. So let me recap what we've just done up to this point. In the last couple of problems, I gave you a function and a point. So I gave you two things, a function and a point on the function, and I said find the slope of the tangent line. And to do that, you use formula 1 or 2, calculate a limit. A limit is a number. So you calculate a limit and you get a number. The number you get is the slope of the tangent line. And that's basically the idea of section 2.7. Now to ease you into section 2.8, let me show you this problem. So let's take a look at this one here. Don't worry about number 2 right now, we'll do that later, but let's just focus on number 1. Look what it says. It says find the slope of the tangent line to the function at the point x equal a. Basically what I'm trying to say here is, I'm giving you a function, but I'm not giving you the point. I'm saying the x-coordinate of the point is a, but I'm not really telling you, is it 2, is it 5? I'm not giving you the number. What we're going to do is we're going to find the slope of the tangent line anyway by using the same formula 1 or 2. I guess we'll use formula 2 here. And we're going to find the slope of the tangent line without plugging in the number a. In the last problem we did, we put, I think what was it, 2? We put 2 in for all the a's. This time I'm not going to plug in anything for the a. Since I'm not going to tell the formula what a is, when I'm done, the answer that I'm going to get for the slope is going to have an a in it. So let's go ahead and use the formula 2, and let's do this problem again. I'm not going to plug in a. So the formula for the slope of the tangent line, the notation was f prime of a. And again, I'm not putting a number there, I'm just leaving it as a. And it was limit h goes to 0 of f of a plus h minus f of a over h. Okay, now what I'm going to do, again, had I given you the point, you would have changed all the a's to that number right now. Since I'm not giving you the point, let's just see what happens. So when I plug in everything, so there's the h, here's the minus sign up here. F of a, what does that mean? That means change all the x's to a. Whatever's in the parentheses, you change all the x's to that. So instead of that saying x cubed, it's going to be a cubed. And then we're going to have minus a there. So here we're going to have a cubed minus a. Over here, what am I going to do? Well, it's a little nasty, the parentheses, right? But whatever's in the parentheses, a plus h, I have to change all the x's to that. So instead of x cubed, it's a plus h cubed, and then minus a plus h. So it's going to be a plus h cubed minus a plus h. And I'll put all this in brackets. You don't have to put the brackets, but just so I could tell you that this bracket is f of a plus h, this bracket is f of a. If you don't put brackets, at minimum put some kind of parentheses because you're going to have to distribute the minus over here. Alright, so let's go ahead and see what this limit is. Okay, so one more time, please understand what's happening here is I'm giving you a function, but I'm not giving you the point. You can use the formula anyway. You can leave the a's in there and see what ends up happening. Okay, so let me go ahead and multiply this out. Again, if you need to, it'd be nice to have that formula memorized. Otherwise, you're going to have to write a plus h times a plus h times a plus h and multiply everything out. We'll go ahead and just write down the answer here. It says a cubed plus 3a squared h plus 3ah squared plus h cubed. Then I'm going to distribute the minus there, so minus a minus h. And then minus a cubed plus a, again it's plus a because I'm distributing this minus here, all over h. Now I want you to see, I mean, what's the problem? I want to plug in 0 for h. I can't because there's an h down there, so I'm hoping eventually it cancels. First thing to notice is up on top, a lot of the terms have h's in it, but the terms that don't have h's in it cancel. You see this a cubed cancels with this minus a cubed here, and this minus a cancels with the plus a, and everything else up on top has an h in it. Let me go ahead and rewrite it again. 3a squared h plus 3ah squared plus h cubed minus h all over h. Now that all the terms up there have an h, I'm going to factor out the h. Notice I'm writing limit every step of the way. So factor out h from the top. We're left with 3a squared plus 3ah plus h squared minus 1. And now the h's cancel. And now I can plug in. So, okay, so you write limit every step of the way until you're ready to plug in. As soon as you plug in, I don't have to write limit anymore, so let me scratch that off. What do I plug in 0 for? For the h's. Don't plug it in for the a, just leave it there. So this is 3a squared plus, that'll be 0, that'll be 0. So 0 plus 0 minus 1, and the answer is 3a squared minus 1. So look what happened. If I only give you the function, and I don't give you the point, then when you go and you calculate the slope of the tangent line, you get a formula that has a in it. The wonderful thing about this formula now is that I can go and find the slope of the tangent line at any point I want. You just have to tell me what a is, and I can plug it in. If you look at part 2, it says find the slope of the tangent line at all these different points. Had you used Formula 1 or Formula 2 and told me the point at the beginning, you'd have to do a long calculation for slope of the tangent line at 2. You have to do some kind of limit like this. Then you have to do it all over again for 5 and all over again for -1. But this way, if I don't tell you what a is in advance and we calculate it, we get a formula that has a in it. And now I could find the slope of the tangent line, all those points, by plugging them in one by one. Let me go ahead and write down what we have here. So this is f prime of a, which is what we're calculating, equals 3a squared minus 1. So now if I want the slope of the tangent line at 2, what do I want? I want f prime of 2. So just change whatever's in there to 2. So I have to change the a to 2. We got 3, 2 squared minus 1, which is 11, which is what we had the last time that we did this problem. Okay, f prime of 2 is 11. If I want to find the slope of the tangent line at 5, I don't have to redo the entire calculation, just plug in 5 to this formula. So you get f prime of 5. And so you change the a to 5 there, and you get 3 times 5 squared minus 1. What is that? 75, 74. The slope of the tangent line for that one. If I want the slope of the tangent line at -1, again, don't have to redo the entire calculation. Just plug in -1 for the a there. So this is f prime of -1. equals 3 times negative 1 squared minus 1. So 2. Looks like the slope is 2 there. Okay, so that's the wonderful way of the wonderful thing about not plugging the point until after you've calculated the limit. So you leave the a in there, calculate the limit, and you get a formula. So that's what they call the derivative as a function. So the derivative at a point, section 2.7, the derivative at a point is a number. So you have to do a long calculation to get each one of these numbers. But now, again, I'm not giving you the point. You find the limit, it's got an a in it, and then you can find the slope of the tangent line, all sorts of points. So we have a formula for this. Okay, so then I guess what I want you to think of is that f of x is a function. And then if you want to find the slope of the tangent line or the derivative, that's f prime. It's also a function. So f is a function, and if I say find the derivative, pay attention to what I'm saying. I'm not saying find the derivative at a point. If I just say find the derivative of the function, then I'm asking for another function. If I say find the derivative at a point, I want a number, I want the slope. But if I say find the derivative, and I don't give you a point, then we're looking for a function. So the derivative of this is this. If this is a function, the only difference is normally when we have functions, we have x's as the input. This time it has an a as the input. And you know, we like to have x as an input. So what I'm going to do then is I'm going to take this formula. The letter doesn't really matter. The letter just stands for our input. So I'm going to change the a's to x and write down that the derivative of this function is 3x squared minus 1. So all I'm doing is changing all the a's to x. So if you get a problem that says find the derivative of a function and they don't give you the point, then here's a function. I'm asking you to find the derivative. I'm asking you to find another function. And this is the function. This is the derivative. And what's the use of this derivative? Is it'll tell me the slope of the tangent line at any point I want, just plug in. So I want the slope of the tangent line at these points, you plug it into this function. This function gives you y coordinates, this function gives you slopes of tangent lines. So that brings us to formula 3, which basically this formula is exactly the same as formula 2, except I change all the a's to x's, because if you leave the a's in there, the formula will have a's in it, and I want the formula to have x's in it, because functions usually have x's in it. So anyway, definition of derivative as a function. Okay, formula 3. Given a function f, the derivative is this function. This is exactly what it said in formula 2, except I have an x here, here, and here instead of a's there. Okay, so we have this derivative, and again, derivatives don't always have to exist. So if there's any places where the derivative doesn't exist, we'll say it's not differentiable at that point. We'll talk about that later. For now, let me go ahead and just do one more example of finding the derivative of a function using this formula. We didn't exactly use this formula yet, we used it with the a's in there. Okay, before we do an example of using formula 3, I just want to make sure we understand what's going on here. So let me take a look at this example here. So let's let f of x equal x squared. So there's a function. Now if I ask you for the derivative of this function, it's another function. Now I'm just going to write down the answer here because I know it. The derivative is 2x. You can use formula 3 to figure that out. There's also a faster way in chapter 3 to figure that out, but since we're not in chapter 3, you're not allowed to use any of those tricks to find the derivative really fast. When we get there, you can use them, but until then, the only way you can figure out this derivative is using this long limit calculation. But again, that's not what I'm going for here, so you can go and figure out why this answer is correct on your own. But I just want to make sure we understand what's going on here. So here's the function that's given. This is the one whose graph we care about. Let me go ahead and draw the graph here. So here's the graph of f. We all know what the graph of this one looks like. So it's a parabola, right? Something like that. Okay, and the derivative is this. So let me just pick a random point on this graph, and let's say the x-coordinate of this point is 1. Well, if I want the y-coordinate of this point, what do? Plug in the 1 to the function. So the y-coordinate, so f of 1 is 1 squared, which is 1. This is the y-coordinate of that point there, okay? But what does this function tell me? This is another function. It tells me the slope of the tangent line at this point. So if I drew a tangent line, let me just draw a little one. The slope of this would be, how do I figure it out? Plug in 1 to, so slope of the tangent line at this point, plug in 1 to this function. F prime of 1 will be the slope, and it's 2 times 1, so it's 2. This is the slope. So slope of that tangent line, oops, I already wrote it. Slope of the tangent line is 2. Okay, let's just go ahead and pick, one more point here. Let's say this is the point, this is some point on the graph, and let's say the x-coordinate is -3. Again, I have two functions here. This is the function that's given in the problem. That's the one whose graph we care about. I'm not going to graph this one, but once I give you a function, the derivative is another function. And what does this derivative tell you? It'll tell you the slope of the tangent line if you plug in a number for x. What if I plug in a number for x here? What will it tell me? The y-coordinate. So at this point here, if I want to know the y-coordinate of this point, whatever number goes there, you plug into the function. the one that you graphed. So it's f of negative 3, it's negative 3 squared, which is 9. But if I want the slope of the tangent line there, let me draw something that, you know, sort of tangent line, because my drawing is not very good there. If I want the slope of that, well, to get it, you plug in negative 3 to this function, because that's the derivative and it tells you the slope of the tangent line. If you plug in negative 3 there, you get 2 times negative 3, which is negative 6. So the slope of this line is negative 6. Okay, so that's the story there. Okay, so let's go ahead and do another example of calculating derivatives using formula 3. Look again at how this question is worded. It says use the definition of derivative to find the derivative of this function. So I've given you a function. I'm asking for the derivative. Notice I didn't give you a point anywhere. So this is a function. When I say give me the derivative, what do I want? I want another function. How do you get the function? Use that formula for the limit for the derivative, which is this. So f. This is what we're going to use. This is formula 3. Its limit. What is it? It's the formula is f of x plus h minus f of x over h. And you just plug into this, and when I'm done, I will end up with a function. That will be the derivative. Okay, so let's put h down here, minus f of x. F of x is just this, so we got square root of x after the minus sign here. What's f of x plus h? Again, whatever's in the parentheses, so x plus h is in the parentheses, you have to replace that x with x plus h, so it's going to look like that. So I have to find this limit. Now notice there's an x and an h in here, but this says h goes to 0. So I'm trying to plug in 0 for h. That's the idea. You can't plug in 0 for h because you get 0 on the bottom. If you plug in 0 for h on top, you get square root of x minus square root of x, which is also 0. So this is the limit of the form 0 over 0. Don't plug in 0 for x. We're trying to plug in 0 for h because it says h goes to 0. But the limit of the top and bottom are both 0. So that means we have to do some algebra. And the algebra we're going to use, I'm sure you guessed it, you're going to multiply top and bottom by the conjugate, square root of x plus h plus square root of x, square root of x plus h plus square root of x down here. Now, I'm going to multiply out the tops, but not the bottoms. Why not the bottoms? Because I'm hoping to cancel the problem. The problem is this h here. So I want to cancel the h. So don't multiply out and mess it up and tangle it up with this other stuff in the denominator. So just copy it down and hope that after I multiply out the top, it cancels somehow. Okay, when you multiply out the top, you get x plus h minus x. Okay, so what's the numerator? The x's cancel, you just get h. The bottom is h, square root of x plus h plus square root of x. Now the h's cancel, and you get limit h goes to 0 of 1 over square root of x plus h plus square root of x. Once the h canceled, now I can plug in 0 for the h. So you plug in the 0, and you get 1 over square root of x plus square root of x. Notice once I plug in, I don't write limit anymore. So this just becomes square root of x, because it's x plus 0, and then square root of x, and this becomes 1 over 2 square root of x. So what I just found out is f prime of x, which is what we've been calculating, is 1 over 2 square root of x. Okay, and again, there will be a much faster way later. For now, this is the way you're going to do it. So one more time, I said, find the derivative of this function. The answer is this function is the derivative of that function. And then what's the use of it? Well, it tells me slopes of tangent lines. So if I want to find the slope of tangent line somewhere, now I can plug in the number. And that's what step number 2 is going to ask you here. It says find the slope of the tangent line to this function, so the same function we've been working on, at this point. Okay, or at these different points. So to find the slope of the tangent line at x equal 1, the slope of the tangent line is f prime of 1. That's the notation. You just plug in 1. You get 1 over 2 square root of 1, which is 1 over 2. So the slope at 1, I didn't have to do a long, lengthy calculation. I just did one long, lengthy calculation. Then I plug in the 1. If I want to find the slope of the tangent line at 4, what do? Plug in 4. Where? To the derivative. Don't plug it in here. If you plug it in here, it'll tell you the y-coordinate of that point. I don't want the y-coordinate. I want the slope. You plug it in here. F prime of 4 is 1 over 2 square root of 4. Square root of 4 is 2, so we got 1 over 4 there. Okay, slope of the tangent line at 9. Again, you just plug in 9 to the formula. So f prime of 9 is 1 over 2 square root of 9. 2 times 3, that's 6 there. And the slope of the tangent line at 16. Now you could do this forever, right? F prime of 16 is 1 over 2 square root of 16. Square root of 16 is 4, so 2 times 4 is 8. Slope of the tangent line is 8. I can find the slope of the tangent line at 100 points in a very small amount of time instead of doing 100 long calculations. So that's the derivative as a function. So one more time, let's recap that. If I give you a function at a point and ask you for the derivative at the point, it's the same question as asking you to find the slope of the tangent line at that point. You'll use formula 1 or formula 2, and when you're done finding the limit, you'll get a number. That'll be the answer. That'll be the slope of the tangent line at that point, or the derivative at that point. That's section 2.7. But in section 2.8, I'll say just here's the function, not giving you a point, find the derivative. When you find the derivative, you're going to be finding a function. And from now on, starting in chapter 3, when I say find the derivative, you're finding a function. How do you find it for now in section 2.8 anyway? You're going to use this formula here. This formula will give you the derivative. It'll be a function. And the good thing about the function is it'll tell me the slope of the tangent line at any point I want afterwards by plugging in numbers. Okay, so again, instead of doing 100 long calculations using formula 1 and 2, you can use formula 3, do one long calculation, and find the slope of the tangent line at as many points as you want to find. Okay, so now all I want to do is talk about a couple of other results in this section 2.8. Now, this video is not covering all of section 2.7 and 2.8, but it's covering a lot of it. The stuff that I don't cover, obviously, I want you to read it and learn it on your own. But I wanted to just point out a few things. So the next thing is, we talked about, here's the derivative, here's the slope of the tangent line, here's the slope of the tangent line. But I said that functions don't always have to be differentiable. So in other words, the limit doesn't have to exist. Or another way to say it, this function, if I give you a function and a point, it doesn't have to have a tangent line. So here are a couple of situations, a couple of results, and a couple of ways you could know, oh, it's not differentiable in this situation. So here's the question, how can a function be non-differentiable at a point? So I'm just going to give you three main things to watch out for, that if these things happen, you know it doesn't have a derivative, or it doesn't have the slope of the tangent line doesn't exist there. So here's one result, and I'm going to prove this one a little bit later. It says, if f is differentiable at a point, then it's continuous at that point. So I'm going to actually prove that one at the end of this video, but that's a big result there. If it's differentiable, then it's continuous. It's not the other way around. If it's continuous, it doesn't mean it's differentiable. So when you have an if-then statement, it usually just works one way. If this is true, then this is true, but the other way, if this is true, this might not be true. So if f is differentiable, then it's continuous at that point. Now I wrote down an equivalent form. Whenever you have an if-then statement, there's always an equivalent if-then statement, but you don't go backwards. It's like this. You can go backwards, but you have to put the word not on this side and the word not on this side. So to go backwards, if this is not true, then this is not true. So that's what I wrote down here. If f is not continuous, so not this, then it's not differentiable at the point. So that's the first example. If you have a point on a function and it's not continuous there, it can't have a derivative there. So quick example over here. I'm just going to draw a graph of something that's not continuous. Let's say it looks like that, and then, I don't know, maybe like that. So at this point here, let's say that's the point 5, this function is not continuous there because you can't draw it through 5 from both sides of 5 without taking your pen off the paper. Or another way to say it is the full limit doesn't exist, so it doesn't satisfy the 3 conditions of being continuous. So f is not continuous at x equals 5, and then that means by this, if it's not continuous, it's not differentiable. So f is not differentiable at x equals 5. This is only one picture. There's lots of different pictures you can draw where the function is not continuous. But again, if you know the function is not continuous at a point, then it can't be differentiable at that point. Okay, so that's one result. One way it could not be differentiable if it's not continuous. Another way, if the graph has a corner or a cusp, it's not differentiable. What do I mean by corner? Well, corner, so a quick example, something like f of x equals absolute value of x. The graph looks something like that. Go ahead and draw an x and y axis here. This function is not differentiable at this point. This point is a corner. Okay, it is continuous though at that point. You could draw it through the point without taking your pen off the paper. But at this corner, it doesn't have a tangent line. The main reason is because if you were to, if we call this point P and you had another point Q here, and you look at the secant line from P to Q, well, the slope of the secant line is 1. And if you move Q towards P like this, on this side, the whole time the slope is 1. So you might guess that the tangent line has slope 1. But then if you pick Q on this side, remember, slope of a tangent line is a limit. It's a full limit. So you have to be able to take Q on both sides of P. And if you put Q on this side, then what's the slope of this line? The answer is -1. So in other words, the left-hand limit is -1, the right-hand limit is +1. So anyway, there's no tangent line at this point. Some people think the tangent line is this. Some people think the tangent line is this. Some people think the tangent line is like the x-axis. None of those are right. Okay, there's no tangent line. Oops, lime. No tangent line at the point 0, 0. And another way to think about it is, if you have a point on the graph, if it has a tangent line, then if you zoom in a lot at the point, then the graph will start looking like a straight line. But if you zoom in at this corner, no matter how much you zoom in, the corner will still be there. It won't start looking like a line. A cusp is something like this. So it's almost like an absolute value graph, but you can have some kind of curviness to it. So something like that. So that would be called a cusp, okay? So it like meets there and then like that. So again, this point, it's not differentiable. In other words, doesn't have a tangent line or doesn't have a slope of a tangent line at this point. So one way for it not to be differentiable is if it's not continuous there, can't be differentiable. Another way is if there's a corner or a cusp. And a third way of how a function can be non-differentiable or not be differentiable is if it has a vertical tangent line. So an example of a vertical tangent line, a couple of examples I'll give you. One of them is f of x equal cube root of x. If you were to draw this graph, cube root of x kind of looks like a sideways parabola like that, and then sideways parabola like that. And I'm talking about the origin, so this at 0, 0. At every other point on this graph, it does have a tangent line, but at 0, 0, the slope of the tangent line, well, the tangent line is vertical, okay? If you were to calculate the slope of the tangent line, you get the limit would be some kind of infinity. But remember, if a limit is infinity, that means it does not exist. So if you have a vertical tangent line, the slope does not exist, that means it's not differentiable there. Another example of a vertical tangent line, something very similar to this, is like if I do cube root of x squared. The graph looks almost the same, looks like a parabola going like that, sideways parabola, and then like this. This is also a cusp at the origin. Oh, my picture's not the best. Something like a cusp at the origin, okay? But it has a vertical tangent line again, okay? So there's a tangent line there. So it's not differentiable because the tangent line is vertical. If you were to calculate using Formula 1 or Formula 2 to find the slope of the tangent line at this point, if you did this one, your answer would be, let me see if I can get this right here. So it'd be infinity this way and negative infinity. So the slope wouldn't exist because one side would be infinity, one would be negative infinity. On this one, you would get infinity and infinity on both sides. So the limit would be infinity. But again, if the limit doesn't exist or if the limit's some kind of infinity, it still doesn't exist. So if the limit, that you get from Formula 1 or Formula 2 doesn't exist, then there's no tangent line there. So it's not differentiable. So those are the three. That's not the only three ways, but those are the three most common ways. And those are three ways we'll see in this class. Okay, so I want to just do one last thing to close here, just for fun. Now you're not going to have to prove this yourself or anything, but I'm going to go ahead and prove that one of the results that I just gave you, that if a function is differentiable at a point, then it's continuous at that point. Again, just watch it, check it out. I want you to see how I apply limit laws, and I use some little tricks here. But again, you won't have to know how to prove it. Definitely know this result though, and don't mix it up. Make sure you know that if it's differentiable, then it's continuous. Or another way to say it is if it's not continuous, it's not differentiable. There's two other ways that people say it that are wrong. So don't say if it's continuous, then it's differentiable. That's wrong. And don't say if it's not differentiable, then it's not continuous. That's not right. So try to get the order correct there. It has to either be if differentiable, then continuous, or if not continuous, then not differentiable. So only two ways you can say that. Okay, so I'm going to prove this. So if f is differentiable, what does that mean? That means the limit from Formula 1, Formula 2 exists. The limit for the slope of the tangent line exists. So f differentiable at x equal a means that f prime of a, which is limit x goes to a of f of x minus f of a over x minus a exists. I don't know what that is, okay? I don't know the function even, so I can't calculate this limit. But because they said it's differentiable, that means this limit, whatever it is, exists. It's a number, it exists. Okay, that's good. So now what do I want to prove? So I want to prove that it's continuous at the point. So for a function to be continuous at this point, this is the definition of continuity. I want to prove to limit as x goes to a of f of x equals f of a. Go back to the continuity section, section 2.5, and you see that was the definition. It was really three things, but this summarizes it. Limit as x goes to a of f of x equals f of a. So I want to prove that to you. So here's how I'm going to do this. So limit as x goes to a Now, if you read the book, they do it in 2 steps. I'm going to do it in 1 step, but if you do it in 2 steps, it's more writing and maybe a little easier to understand though. But I'm going to go ahead and do it all in 1 step. It's a little bit less writing, but a little more tricky. So here's the deal. I'm going to do some more to this side, but I'm trying to figure out what's the limit as x goes to a of f of x. Now over here, I'm just going to take the f of x, I'm going to add and subtract stuff. Like, for example, I can add and subtract 1, right? And that's, the 1's cancel, so I do get f of x. But I want to do things in a weird way, so I end up with this limit because I know something about this limit. So here's what I'm going to do. I'm going to first minus f of a and add f of a. F of a is just a number. We plugged in a to the function, so this is a number. So I just added and subtracted a number. Okay, so that should be okay. And then the next thing I'm going to do, now be careful. At this point, you might say, oh, let's use a limit law and do the limit of each one separately. But you can't do that because I don't know if this limit exists or not. I'm trying to figure out what it is. So let's be careful there. You just have to be very careful when you do proofs like this. But again, you don't have to do it. Now I'm going to move the f of a over here. And now what I'm going to do is I'm going to take this part, I'm going to divide by x minus a and multiply by x minus a. Do you agree that if I multiply and divide by x minus a, they cancel anyway? So I haven't changed it. But why am I dividing by x minus a? So I can get this to appear. So what I'm doing is I'm dividing by x minus a and multiplying by x minus a. Okay, so limit as x goes to a of f of x is this crazy looking limit. Now I'm going to use limit laws. Limit laws says I can take the limit of this and this separately because they're being multiplied, and then I can take the limit of that and that separately because they're being added. So we had a limit law about adding, a limit law about multiplying, so I'm going to take the limit of each thing separately. Why am I not taking the limit of every little piece separately? Because I don't know if they all exist, but I know the limit of this box exists. This limit is the limit of a polynomial, so I know what it is, and this is the limit of a number, so I know those things. So anyway, this becomes, after a couple of limit laws, f of x minus f of a over x minus a times limit x goes to a of x minus a plus limit x goes to a of f of a. I know all those limits exist. All those limits exist. This one exists. So this here, I don't know what it is, but this is a number. Some number. What's this limit? Well, it's the limit of a polynomial. You can plug in a for the x. What do you get? A minus a. This limit is 0. Now what's the limit as x goes to a of f of a? Again, don't get confused. There's no x here. So a is a number. You plug it into the function, you get a number. This is a number. So the limit of a number is itself. So this limit is f of a. So what is the limit? It's this number, whatever it is. Okay, I'll write number times 0 plus f of a. The answer is f of a. And that's exactly what I wanted to prove. I wanted to prove that the limit as x goes to a of f of x is f of a. And I just proved that this limit is equal to f of a. And that proves that the function is continuous at that point. So anyway, I know it was a little weird. I did want you to see limit laws. Okay, so we used some limit laws and the fact that I knew this limit existed, so I had to get it to appear somehow. Okay guys, well that's the end of this video for section 2.7 and 2.8. Watch it, make sure you understand everything because it will be on future quizzes and exams and stuff. Also, please give me feedback. Let me know if this video was useful and study hard.